You wake up. Morning light slips through your window. It feels soft, warm, familiar. You've seen this light every day of your life. It touches your face. It fills your room. It makes the world visible. And yet, that light began its journey nearly 8 minutes ago. It left the surface of the sun before you even decided to open your eyes. 8 minutes. That's the distance between you and the thing that makes your life possible. Not far, not really. You could drive across a city in that time. You could boil water. You could scroll endlessly without noticing. But the truth is, that distance is about 150 million kilometers, and suddenly, it doesn't feel small anymore. You are standing on a planet, orbiting a star, at a speed you cannot feel, held in place by a force you cannot see. The sun looks simple, a bright circle in the sky, a thing you're told not to stare at. But simplicity is a lie. Your brain tells you to stay calm, because the sun is not calm. The surface you see, what scientists call the photosphere, is around 5,500 degrees Celsius, hot enough to melt almost anything you know. But that's just the surface, just the skin. Beneath it, something far more violent is happening. Deep inside the sun, atoms are being crushed together so hard that they fuse. Hydrogen turning into helium, matter becoming energy. Every second, the sun converts about 600 million tons of hydrogen into helium. 600 million tons. Every second. To make that feel real, imagine Mount Everest. Now imagine 1,000 Mount Everests. Now imagine all of them disappearing. Every single second. That is the engine of your daylight. That is what keeps Earth warm enough for oceans to exist, and for you to be here. But here's the part that changes everything. The light you see, the warmth you feel, it is not new. The energy created in the sun's core does not escape immediately. It doesn't travel straight out. Instead, it gets trapped, bounced around, absorbed, re-emitted, again and again and again. A single photon, just one particle of light, can take tens of thousands, even hundreds of thousands of years to escape the sun. Think about that. The sunlight touching your skin right now may have begun its journey before human civilization even existed, before cities, before writing, before history. You are not feeling the sun as it is. You are feeling the sun as it was. And that means something strange is happening above your head right now that you cannot see yet. Something is already on its way, something that has already begun. And when it reaches you, it will already be too late. You are standing on Earth, a planet that feels vast. Mountains stretch for kilometers. Oceans span entire horizons. Storms cover continents. It feels big. But Earth is small. If the sun were the size of a door, Earth would be smaller than a coin. You could lose it in your pocket. That bright circle in the sky, it holds 99.8% of all the mass in the entire solar system. Everything else, planets, moons, asteroids, dust, barely matters. The sun is not just the center. It is almost everything. Now imagine stepping closer. Not physically. You wouldn't survive that. But in understanding. The sun is about 1.4 million kilometers wide. You could fit over 1.3 million Earths inside it. 1.3 million. Stack every city, every ocean, every mountain you've ever known, over 1 million times. Still not enough. And yet, even that doesn't tell you what's inside, because the surface is not the story. The core is. At the center of the sun, the temperature reaches around 15 million degrees Celsius. 15 million. There are no materials here, No solids, no liquids, not even normal gas. Atoms don't behave the way you expect. Electrons are stripped away. Matter exists as plasma, a chaotic, charged state where particles move violently, constantly, and in this chaos, fusion happens. Hydrogen nuclei collide so forcefully that they merge. 4 hydrogen atoms become 1 helium atom. But something is missing. A small amount of mass disappears, and that missing mass becomes energy. This is Einstein's equation in action. E equals mc squared. A tiny loss of mass, multiplied by the speed of light squared, becomes an unimaginable release of energy. This is what powers the sun. This is what powers your life. Every breath you take is indirectly powered by nuclear fusion, 150 million kilometers away. But here's the part that makes it unsettling. The core of the sun is not burning like fire. It is not flames. Fire needs oxygen. The sun doesn't burn. It collapses inward while exploding outward at the same time. Gravity pulls everything toward the center, trying to crush the sun into something smaller. Fusion pushes outward, trying to blow the sun apart. These two forces balance perfectly, a constant battle, a perfect equilibrium. If gravity wins, the sun collapses. If fusion wins, the sun explodes. Right now, they are equal, but not forever. And while this balance holds, energy begins its slow escape. From the core, it moves outward through the radiative zone. This region is dense. Photons cannot travel freely. They move randomly, a zigzag path, 1 step forward, 2 steps sideways, 3 steps back, over and over again. It is like trying to escape a crowded room, where every person you bump into sends you in a new direction. This is why light takes so long to escape, not seconds, not minutes, thousands of years. By the time energy reaches the outer layers, the convective zone, it behaves differently. Hot plasma rises, cooler plasma sinks, like boiling water. Massive bubbles of energy, larger than continents, churn constantly. The sun is not quiet. It is a storm, and on its surface, that storm becomes visible. You see sunspots, dark regions where magnetic fields twist and tangle. They look small from Earth, but many are larger than our entire planet. Larger than Earth. Now imagine something even more violent. Solar flares. Explosions of energy that release as much power as billions of nuclear bombs in minutes. And then there are coronal mass ejections. Huge clouds of charged particles thrown into space. If one of these hits Earth directly, it can disrupt satellites, power grids, communication systems. In extreme cases, it could push modern civilization into darkness. And this has happened before. In 1859, a solar storm known as the Carrington event struck Earth. Telegraph systems failed. Sparks flew from equipment. Auroras appeared near the equator. That was before electricity ruled our world. If something like that happened today, it would not just be beautiful, it would be catastrophic. And here is the moment where everything feels small. The sun is just an average star, not the biggest, not the brightest, not the most violent, just average. There are stars in the universe so large that if you placed one where the sun is, it would swallow Earth, Mars, even Jupiter. Completely gone. There are stars that explode with such force that they outshine entire galaxies for a brief moment. And yet, your entire existence depends on this one ordinary star, this fragile balance, this constant nuclear reaction. And here's the question that changes everything. If something so ordinary holds so much power over your existence, what does that say about everything else? that you haven't even begun to understand. You are standing under the sky again. It looks the same, blue, quiet, familiar. But now you know what is above you. Not just light, not just warmth. A star, constantly fighting itself, holding the conditions of your life together moment by moment. Every second, the sun loses mass. About 4 million tons of it, turned directly into energy, gone forever. It sounds like a lot, but the sun is so massive that it can keep doing this for billions of years. And it has. The sun is about 4.6 billion years old. Before Earth had life, before oceans, before anything you would recognize. And it will continue for about 5 billion more years, but not like this. Eventually, the hydrogen in the core will run out. Fusion will slow. Gravity will begin to win. The core will contract. Heat will rise. And the outer layers will expand. The sun will become a red giant. It will grow so large that it may swallow Mercury, Venus, and possibly Earth. Everything you know, gone. Not destroyed in violence. Just consumed, slowly, silently. And after that, the sun will shed its outer layers, leaving behind a dense core, a white dwarf, a small fading remnant of what was once the center of your entire existence. No more warmth, no more daylight, just a cooling ember in the dark. But here is where it becomes personal. You will not be there to see this. No human will. Civilizations rise and fall in thousands of years. The sun changes over billions. The scales do not match, and yet you are connected to it. Every atom in your body was once inside a star. Not this one, an older one, long dead, exploded, scattered across space. Your carbon, your oxygen, your iron, forged in stellar cores, like the one above your head. You are not just standing under the sun. You are made of the same processes, the same physics, the same universe. And for a brief moment, in a timeline that stretches billions of years, you are here, aware, looking up, understanding, just a little. The sun does not know you exist. It does not care. It will continue, whether you are here or not. And somehow, that makes this moment heavier, because the light touching your face right now traveled for thousands of years inside a star, 8 minutes through space, just to reach you and be noticed for a moment before it is gone.